workshop for SAP 2000. Specifically, our speaker tonight will be discussing about the pushover analysis for seismic assessment. So allow me to introduce our speaker for tonight. He is uh, a graduate from Xavier University Ateneo de Cagayan from the Civil Engineering Department and is also currently working at the DPWH Region 8. He is Engineer Garnelo Jose A. Cupay. So good evening, Engineer Cupay.
Hello, good evening. May gabi sa tanan. Engineer, Regional 13 day. Layo kay.
Region 30. Sorry,
Yeah.
sorry.
Yeah, naro ko din sa Mindanao gihapon. uh, with regards sa kung katong okay mag-ask ko something kay naman ko ka ng concern with regards sa katong software niya kay Sir Dex will ask me to kuan ta na to make anang kuan ba to perform ta na the SAP 2000 but unfortunately I was limited by our superior din nga akong gina-use man kay work laptop niya dili ni maka-install og mga software without permission sa mga office. So katong if na someone to sa inyo mga nanay model sa inyo building para later after na ko sa akong presentation we can work on that like interactively para i-guide ta mo para katong kung kinsa tong model na i-present later pwede kamo na din magkuhan kung medyo na mga questions pwede ninyo makuhan tayo share to each other kung sa mga gali ang pag-apply sa mga kailangan niyo i-apply para mabuhat ang pushover sa SAP 2000.
Okay po sir, noted po sir. Thank you.
Recording in progress.
the other groups if we use at least if ever na may questions, and you can always contact me man if you have questions. Mm-mm. Is it okay with the other groups in this in this workshop?
Yes, sir.
Okay. So, uh, do we start na or napay mga napay mga things to say Vice?
I think wala na po, sir.
Okay, so sorry kayo sa akin. Okay, so I can share screen, di ba? I can. Okay.
Yes po, sir.
Hmm. How do you? Okay. Yes. Can you see the screen?
Yes po, sir.
Yeah, okay. Good evening, everyone. My name again is Engineer Garnelo Cupay. You can call me Kuya Garni because I'm not yet that but I'm just a little bit older than you siguro, like 1 year kasi I was born in 1998. Um, so Sir Dex and Sir Ark has told me to discuss to you the pushover analysis, and I'm grateful na um, there are, if I'm not mistaken, there are three groups who are study 3 or 4 groups who are doing their FY on seismic or disaster risk, and that's good because especially here in Mindanao we have been noticing, and we need more of this research to really develop our island. So yeah, and one of the most important things that you have to know when you do a seismic assessment is, of course, the pushover analysis, because it's one of the easiest of the different uh, analysis to prepare for your seismic assessment. Pushover, also called the nonlinear static analysis, is one of the nonlinear analysis. The other one is time history, but that's for a different topic now. It is used to determine the structural capacity of a building or bridge by observing its structural deformations. So if you have gone with your design and gone when you use your RC design, your steel design, or your structural analysis, most of it that you have discussed as of the moment is all focused on uh, moment and shear failure in studying the structural capacity of the structure. In pushover analysis, you focus on the structural deformations. Most specifically, the structure is subjected to increasing lateral forces. Kung sa Bisaya pa ang building or ang bridge ninyo, inyo siyang ituklod o balik-balik sa isa kanang increasing nga load, dugang nga load, hantod sa matumba siya. As the word itself says, pushover analysis. So, kana siya, diretso, murag inyong gipatumba ang building, inyo siyang upon force under gravity loads. So, as I've said earlier, sa inyong model, when you apply it, when you apply your load, you don't need the live load for the pushover. You focus on the dead load. And I think, if I'm not mistaken, Sir Dex has already told you, or Sir Arc, whoever taught you structural structural analysis, or I forgot the subject, na there can be higher moments in lateral if there's no live load existing in the building, especially in an earthquake. So it approximates the sequence of the cracks the yielding and casting cage formation. I will discuss this further mas masabtan ninyo niya with a fun guide. In pushover analysis, in your structure, you set target displacement. Kumbaga, pila ka meters dapat mo move ang inyong building na dapat mo stop na ang pagtuklod sa building. Kumbaga, imagine nimo gatuklod ka sa tao, at what point ka mo stop og tuklod siya kung mabot na niya nga movement. And we observe the capacity of the members through plastic hinges, which is I will elaborate later. So if you have done your model sa pushover, you can see yung SAP, you can see this is a simple model of the structure. These colors, this is the result of this is what you are expected to have this kind of results in your model. Even sa bridge, actually the bridge, it's much easier to do the pushover because you assume the bridge as a one-story building or a structure because there's only one span appear. And you can see nga na yung mga points, that colored points, that's where you observe the failure. When you think kasi of pushover analysis in your thesis or in designing buildings, ang inyong mindset dapat is kanang unsaon siya, unsa ay ang way mo fail ang isa ka structure. For example, kung maglinog, in what way siya mo fail? Pwede siya mo fail nga mo crack or mo tagak ang isa ka end sa beam. Pwede siya mo fail nga bubuto ang column or ang beam. And you observe that phenomena sa inyong model at these colored points. So elaborate na to later pag abot na sa katong model sa tong isa ka group. Theoretical analytical lang siya concept. If you are familiar with the stress strain diagram in your strength of materials, if you remember this, can you see my mouse pointer? Can you see the mouse pointer pa?
Yes po, sir.
Okay. If you remember your elastic your stress strain diagram in strength of materials, strain and stress, di ba stress is correlated to your force because it's stress is force over area, and your strain is correlated to your deformation sa imong structure, so or displacement. So actually ang pushover curve and the stress strain diagram is closely related. When you see here natawag yung similarity, when as a member or a structure is subjected to a wait lang, ako yung panang pen. When a structure is subjected to a lateral force like earthquake, it experienced displacement. So wait lang, akong ikuan. It's better in color. It moves. There's a displacement of the structure. And remember the nodes here, these colored nodes. You observe the failure of the structure through this movement. So parang you observe this displacement. And the basic concept of pushover, you check na this displacement, the displacement of the node will not reach this point of collapse. So if there's a force, increase of force until it reaches this certain displacement here, you make you are pushing your building through the limit so that you can see nga mabot siya ana. Mo na ay ang failure dia siya mo fail because that's the point of doing the pushover. Kanang wala pa earthquake. The misconception most of the time, even us during our time when we did FY, na pushover is already the earthquake. No, you're just approximating a random random loads, like for example, what 110 kilonewton, you continuously add 10 kilonewton every step in pushover, like 10, another 10 plus 10 plus 10 until it reaches 60, and then you observe nga at 60 kilonewton it reaches a displacement of 400 mm ang node, and based sa inyong analysis 400 mm is already at the point of collapse. So that's how pushover works. You're trying to create a graph where it presents now at what load does the structure reach the failure or the collapse displacement here. So how much force and how much displacement happens. And as you can see, parang weird siya kasi it does not fail here. It continues to sustain here. If you can see also the stress strain diagram, there's a point na after yielding, the structure can still sustain. It does not get kanang damaged or destroyed, but the material property are slowly deteriorating. Kumbaga sa steel pulp, and if you kanang see na kanang a plastic bottle na kanang wait lang. I think this is so that you can clearly understand this concept na sa have you already discussed nonlinear material properties in your classes? Is it okay to ask?
Murag wala pa ata,
Have you already
sir?
discussed?
Or nalimtan lang.
May I ask kanang so that I can bising kon ba kanang medyo dili mo ka follow to bising na yung mga na-skip no. Hello. Oh. Hello. Hello. Can you hear me?
Yes, sir.
Sorry. Kasi na-disconnect ako. Parang have you finished na your strength of materials, diba? And RC design?
Yes pa, sir.
Okay, so okay. That's enough na. Are you already finished with earthquake engineering with Sir Dex, or I don't know who's teaching earthquake engineering right now?
Wala pa po.
Wala pa. Okay. So, sige. So at least kailangan yung kailangan din you need to understand a little bit of the concepts of earthquake at the later part here. I think Sir Dex will supplement that part. Okay, so sa stress strain diagram, the elastic limit is the part of the is the part of the kanang failure level sa isa ka member, na as long as it's within that, the member will not fail through a plastic method. Kumbaga yung member will stay the same material all throughout. But when it reaches the yield point and beyond, when it reaches the plastic zone, mura na siya plastic ba nga. Pag ma-deform ang plastic, mas paspas na siya, ma-damage. Like kanang kung inyo siyang stretch out ang plastic or inyong kumuton, pag inyo kung mabuta siya sa katong murag mo crack na bitaw siya, kanang murag mo inat na bitaw, mas dali na kanang siya balion compared sa kanang ang plastic kay kuan pa siya. So mga po na sa members. So this is also what you observe here in the pushover curve yapon. Okay. So sa SAP, this is what you are what you should be expecting na result. This base displacement and base reaction, same here. So this is the base reaction, and this is displacement. As you can see, this is what happens when the member reaches at this point. The change na yung material property kitungod dako na kayo yung load. That's why down din siya diretso. So this is very dangerous, especially in earthquakes. We don't want this to happen to our buildings. So You have to know when this happens and at what displacement and at what base reaction it happens. Okay. So I have spoken repeatedly what a plastic hinge. So a plastic hinge refers to the deformation of a point on a structural member wherever plastic bending happens. So as I've said, when the structure reaches yield point, it becomes a plastic. It goes beyond that. It enters a plastic zone. So at this point, ang material na sa structure, like example, a steel, will be much more easier to damage, as you can see here. Like at here, gradual pa ay ang pagka damage, gradual. Here plastic zone, but when it reaches here, splack down, the displacement goes. It just simply means that the structure has already failed. So this plastic hinge will be your guide. These nodes will be your guide in doing your pushover later. And here is a legend to guide you. Like it's based from FEMA 356, basic basic. I forgot the B. This one is immediate occupancy. When a certain node reaches the dark blue, it simply means na people has to evacuate. In life safety, blue green, people if there are trapped people has to be saved. And then the collapse prevention, of course, when a building has this node, when it reaches this node, retrofitting is recommended and collapse, and then, yeah, the worst destroyed. So just a run through the concept. When a member forms a plastic hinge, it means it has lost the capability to resist moment. So when it turns into a plastic hinge, simple, it cannot resist moment. So it will fail in the moment. As you can see, there's a lateral force, and this is the weight of the building. And then elastic behavior. There's just a little deformation, but after the earthquake, it's fine. A plastic behavior, there's an additional displacement because the member has changed its properties. It becomes plastic. Oh, I think that's more clear. Na tungod kay nahimo na siya, na-change na ang property sa member, mas mudako ang yang displacement or yung deformation, which leads to the latter part, collapse. At a later part, we will discuss this because all throughout, kung na-discuss nga, it's about the building's capacity. It's about the building's capacity to resist the lateral force. So that's what the pushover curve represents. At this part, I think this is not covered na sa ako i-discuss, maybe someone else. You need this data if you haven't got it yet to create a capacity spectrum, because I have read all your studies. Most of you are doing a capacity spectrum method analysis, and you have to convert the earthquake data, this time history data, into a response spectrum data using the prism. You change the what's the difference between this one is the raw earthquake data, like what is the acceleration of the earthquake in terms of gravity g with respect to time. This one, this is a response spectrum. This is the earthquake graph in terms of period, which will be explained further by Sir Dex in earthquake engineering. Period is the time a building oscillates back to its original form. So wait, just a little. If this is your building, no. I think this is a better presentation. This is your building. When it moves to the side, the moment it goes back, the time that it goes back to its original position here is your period. After it sways after it sways back and forth. So this period is not the building's period. It is the period of the soil. So when this earthquake happens, this is the period of the soil when it goes back to its original position. And this is important because there's this term called resonance. Kindly take note of this resonance. This is very important. Even after you graduate, you need this idea if you pursue design. Resonance is when the building's period and the soil's period are equal. The moment it becomes equal, the building is heavily damaged or even collapsed. I cannot explain it further because I have reviewed it thoroughly, pero that's the idea. You can ask Sir Dex. So, and why is it important? Because on the next slide, with because this is your main goal for your pushover. Pushover is really too short. Your goal is just to get this curve. This is the capacity of the building. You continue to push the building. You have this displacement. That's all. You just do it in your software. But why is resonance important? This is the idea of resonance. This point here, the displacement of the earthquake and the displacement of the building meets. That's when a building or a bridge fails. Question so far. Kaya ba saying ko, at least before ta mag-kon ang next medyo pa na siya. We'll go na to the sa SAP na idea before we continue. Are there any questions? Is it okay to open this part with questions? Kasi na yung nalibog ba? Yeah, I felt the same too before. Hello?
Sir, can I ask again about like the resonance? Unsa gala to displacement sa building and
Okay. Ako i-repeat na lang. Is it okay if I speak in Bisaya? Moral mas masabtan man. Okay. Resonance happens. Okay, I'll draw two circles. And then this is your soil. This is your building. There are periods. Like imagine this one. This is the perfect example. A pendulum. I think it's better to do it here somewhere. Imagine a pendulum. Diba it sways there and it sways there. The time it takes, diba, it starts here and then goes there and it goes back. The time, okay, so let's call this T1 and this one T2. The time it takes to get back to its original position, that's your period. Okay, so back here, here's your period. Here is the period of your earthquake. When you convert this data, you have a software to do this. You don't have to solve anything about this. You convert this to the response spectrum. This is the period. The time it takes for the soil to come back to its original position. When the building's period becomes equal to the period of the soil, the building fails. It maybe doesn't fail directly, dili siya ma-fail diretso, but it is bound to fail. It's already a failure. That's the reason why there are dampeners in high stories. If you have went to Taiwan, to Japan, and you visited the higher stories, there are dampeners because dampeners are natural period breakers. Kumbaga, they break the period so that there's no chance for the building and the soil to have equal periods. And actually, it's a very bit confusing here because the capacity spectrum, you have to convert this again from acceleration to period to acceleration displacement. You just need the software for this. I'm just explaining the concept so that when you get to the software, you get the reason why you're doing it, so that you won't get confused through the way when you do the 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 steps or the methods that you have to do. You are converting the acceleration and period to spectral acceleration and displacement, spectral displacement, so that you can plot it together. This is the response spectrum. This is actually a cleaned one, because this one it's too uh, chaotic. In SAP, it becomes a clean one, and it meets with your pushover curve. And this is your target, actually the performance point, because this is the points where a building fails, or not the building exactly, but a certain member fails in your building, depending on the scope of your study. So, okay. Did I answer your question, or it's still too confusing?
Yes, sir. Thank
Okay.
you.
Okay. Okay. This is how it looks. In SAP, this is your pushover curve, and then the data from your earthquake. This is the red one. The goal is to There are a lot actually, because these are different PGAs, which it will be explained again later. Yeah, actually, it's medyo complicated, but when you get the hang of it, you'll understand that. So yeah. So your goal talaga is in pushover is to get this curve. This actually it's not really a curve, but yeah, it depends lang sa katungkuhan. Pero this graph, you have to get this graph, this green line. You have to get this green line, which represents your building or bridge. Okay. And another note, especially that you're doing a research, if I'm not mistaken, all of your buildings are low-rise buildings. Capacity spectrum and the pushover analysis is only ideally applicable. I mean the capacity spectrum is applicable only to ideally applicable to low-rise buildings, because as you can see, when we use the response spectrum, it only caters to low period buildings, which oh my god, I forgot. Okay, in your earthquake, it will be discussed to you. Lower buildings, smaller or lower rise buildings are more prone to to higher period earthquakes. This is here. Lower period earthquakes. Okay, again, the lower rise buildings are more prone to damage by these lower period earthquakes compared to the higher rise buildings. The high rise buildings are more prone to the high period structure earthquakes. So yeah. Actually, we'll be discussing earthquake, pero yeah, that's the idea. So in simple terms, just use the capacity spectrum if you're analyzing low-rise buildings or bridges. Okay. Can we proceed to the software? Can someone share their screen for the your SAP?
Hi, Garn. Garn, can you hear me?
Hello, sir. Yes, sir. Yes,
Hello.
sir. Hello,
Can
sir.
tingit ako ba? Can I ask a question sa kadali ha?
Okay, sir. Sige, sir.
Oh, hindi ko familiar with capacity spectrum manggod, pero I understand from pushover analysis you get the performance or the damage level of the building with respect to the ground acceleration. Sakto ba ko?
Pushover, sir. Sa pushover lang, sir, kay you're just getting the kanang displacement of the building with respect to the increased lateral forces. So every time there's additional lateral force, the building is displaced. It is displaced farther. So
Okay. So katong na-confuse ko gamay ba? Unsa to imong response curve? Was that the demand?
yes, that's the demand, sir. That's the demand. The response spectrum is the demand.
The response spectrum is the demand.
Yes, sir.
Unsa nga analysis ang gibuhat para makuha ang demand gani Garn?
We got earthquake kung for the FY kanang kuan karon purposes ang gigamit nga demand is mga actual earthquake data na iyang time history, convert din nato siya to response spectrum. You can do it
Okay. So, a linear time history.
Yes, sir. Linear time history pa siya, sir. As of the moment, oo.
Okay. So, kato no, the for pushover, you get the performance or the performance of the structure mismo with respect to the increased loading. So
Yes,
that's what
and
you get with pushover. And
yes,
what
sir.
you get with linear time history analysis is the demand or the so na ito yung term sa imong figure kanina.
Uh, response spectrum. Oh, response spectrum, sir.
Okay. So kato klaro na rin siya. Thank you very much, Garn.
Okay, sir. Okay.
Okay, maminaw
You're
ako.
welcome, sir.
Please continue.
Sige, sir. Kisa to magkuhan sa katong ilang structure kay I can guide you through the one. Oh, this is unsa dako lagi kay ni nga building. Hello?
Yes po, sir. Hospital po, sir. Pero wala pa siya nahuman, sir, sa katong sa ramp stairs, pati sa balcony po, sir, sa front. Kato na lang kulang din, sir.
Ramp of stairs. Pwede siya
Pati mga restraints po, sir.
pwede siya stick model kay para dili ko. At least ang one side lang bala ang pika side okay rin siya. Or stick model na lang duha, 3D ang isa and then the other side would be kuan kanang X and Y plane na stick model din. And the right side should be 3D para mas siya.
No.
Ay 3D din na siya. Okay. Yeah. Okay. Ano sa tanan.
Ay.
Pwede na to. Parang kuan lang. Mas maayo actually nga kuan siya kanang elevation siya nga view. Okay. Actually, this is a really it will really take a long time to model the structure. Pero sige, kanang first when wala pa mo naka-define, i-click ang define ninyo. Define. And yung imuhang load cases. Click the load cases. Load cases. Okay, so you only have kanang dead and modal. Okay. Since wala pa mga kuan, click the kanang click i-modify na siyang load kanang dead load. Modify show load case. Bala pag wala pa siya load karon, i-modify when you do your kuan kanang push over analysis kanang your dead load, di ba initially mag-linear analysis mo. When you enter na the pushover analysis, you convert the load case type. Click the load case type. Kanang kita mo ng drop down box to the right. There's a kanang non-linear. Wait lang. Ay back sa click sa na siya. This one na. Non-linear. I-click ng button nga non-linear. So you have to click you have to change it to a non-linear. So the same pa rin ang and your load type, your scale of your dead load should be -1 because your dead load is this scale factor here, loads applied, it should be -1 because your load is gravity load, dead load. So that's the thing you have to adjust lang sa inyong dead load. So that's okay na. That's okay na. And then you add a new load case. Add a new load case. Call it push. And then click the drop down box at the right. Wala siya push over. Hello, hello. Can you hear me? Sorry, disconnect ako
Ah,
kayo.
yes po.
I have very bad internet. Okay. Oh my God. Sorry. Your pushover is still static because it's nonlinear static, pero you change the analysis type to nonlinear. That button, and then you click the so initial conditions. Your dead load would be the start of your pushover. So you use the continue from state at end of nonlinear case because you kanang in pushover you consider na the gravity loads. So you continue from an at end of nonlinear case. By the way, the name of your push con, this is just for the sample, but since some of you have buildings that are irregular or big buildings and bridges, you can assign here in the load pattern, you change it to load pattern here at the bottom. Loads applied. Um, it becomes acceleration because as I've said, push over con it, it, you're pushing the building, and then there's in the load name there's ux and uy. If you have a irregular building, you have to put both, and then the scale factor would depend. Can you move the this kind of toolbox to the side so that we can see the x and y axis in the 3D view? Can you move it to the left a little? You can see there at the bottom, there's an XYZ. So your push, okay. And okay, as you can see, the the x direction is pointed to your right, and then the y to hello. Sorry. um
Hello po, sir.
oh, in your load pattern, you change it to acceleration. To acceleration to your right. Loads applied. Loads applied. There, acceleration, and then your scale factor would depend where do you want to push your building from. If you want to push it from the side of your from the side here towards the assigned arrow of the x-axis, you just use 1. But if against it, you just use negative. The same goes for your y-axis push. So it's just assume mga 1. Okay, so that's your ux and uy. For it depends on your scope of your study. If you're just pushing it at one side, it's ideal that you push it at two sides especially those irregular. If I'm not mistaken, who was the irregular structure, the L1? No, so you need to observe from both sides. So you can, and here this is critical. Go to the other parameters, click the load application. Other parameters at the bottom, click modify or show. This is very critical. Take note of this. From full load, you change the load application control to displacement control because your pushover will be focused on your displacement control. And what are you using? Use monitor displacement. This is what I told you about the target displacement. This your target displacement will be dependent upon you. You're assuming, for example, actually supposedly in this analysis you gonna, since you're assuming a number na one, parang rule of thumb na ba for designers na okay, at this point sure na this building will run. For you, I suggest you start at 300 to 400 mm. So I think you're using meters. Okay, so you can just use 0.3 for your monitored load displacement. Okay, that's pretty sure when when the building is when a node in the building is displaced 300 mm, it is already at a plastic hinge na zone, plastic zone. That one of the members will already be damaged in a plastic manner. And this monitor displacement, take note, you have U1. Can you click the drop down? Okay. Monitor displacement. Can you minimize this one for a minute? Can you just remove it, just close it muna for the meantime, close it. And go to the 3D view. You can press OK. You can press OK. You can edit it anytime.
Hello,
Okay.
Garn. Excuse.
Hello, sir? Yes, sir?
Tunggan ko, sorry. Clarify lang na ako ba? Kaning imong pasabot nga displacement, are you referring also to the maximum interstory dip?
No, not yet, sir. That would be done na sa later nga kanang pa. Ang monitor displacement is just kanang asa nimo ipa-stop ang pushover nimo, like when the monitor node like this part, sir, ako ikon, sir. So you have to choose where to put your kanang where you monitor the displacement. You have to choose a node. Ideally, it's kanang good to choose somewhere in the corner side, at the most corner side, like end side, like yeah, you can choose there. For those who are this part in the pushover, in pushover, you have to consider what failure mode are you trying to observe. Because there are different types of failure. Your member can fail either from shear, from torsion, from flexure or moment, or interstory drift. If you are in your study, if you are observing interstory drift, your monitored node should be at the topmost node of your corner. So yeah, there, that one. Click that node. What is its number? How do you right click? I think it's right click, or how do you see the properties of the node? It's label 938. Okay. So that would be your focus node. So you can go back to the define pushover earlier. You can go back there. Load cases, modify, and then display, modify, or show. You input what number, at joint number. You input that number there. You place it. Was it 938? Forgot the number.
Yes po ata, sir. Wait, double check na lang.
Sige. You can go back. The idea.
Sige.
Yeah. The idea of this part is you assign where it happen, where you monitor the displacement, because that's your kumbaga parang sa inyong moment, that's your moment, that's where you, I forgot the term, parang you base your moment arm diyan ka, diya ka mutuyok kumbaga. So same gyud sa pushover, diya niya tan-aw ng displacement kung igo na siya 400, mo stop na ang pushover, and yeah, every other node actually will also move, which is be represented later in your pushover. So that will be okay na. Okay. Assuming you're doing interstory drift na failure, which is good. Go to the result save, modify or show. This is for your later one, so that you multiple states, because you're not just observing the final state. You want to observe each state. 10 to 100, pwede na siya. For the sake lang of presentation, you can adjust that if mag-lag ang inyong stop. Pwede ninyo pagamayon, like from 1 to 10, pwede po siya from 1 to 50. Minimum number kan. Depende na sa inyo kung mag-lag, kung kusog ang inyong laptop. Para ni siya later sa inyong results kung pila ka steps ang inyong i-observe. And sa nonlinear parameters, modify or show. Actually, this part this is kumbaga sa solution control. In the later part, you can research in this. It is very dependent on the capacity of your laptop or computer or PC, whatever you're using. I suggest nga, actually, ikuha siya kanang charge to experience. Mag-sap mo, as much as possible ayo yun mo pag laptop kay naguba ko laptop tungod ani kay akong save files ni abot og like 60 gig just for one bridge. So if you are doing this kind of building, pretty sure it's moabot ni terabyte actually ng mga data. So mo ni and kanang mga kuha nimo kanang maximum null zero, you can adjust that. You can research actually na yung mga sa YouTube na mas kuha man sila kung kuha. Kani at least makabalo mo nga kung if ever mag-lag niyo yung laptop, kabalo mo asa mag-check. Dili mo mag-check sa nonlinear parameters. Inyong adjust ng mga tolerance factor ni. Okay? So, dili na ako magkuhan kay dili mo ko kabalo sa inyong mga PC man. So, ana siya. Okay. So actually this is ang yung load case data for the pushover analysis. Ang inyong checklist ani dapat kindly take note of this checklist ninyo. First, pwede ko mag-share screen ka dali para i-present na ko ang checklist.
Okay pa sir. Mag-stop sa ko share pa sir.
For the meantime, para at least gets na ninyo kani mo man critical, mo man medyo libog na part. Okay. Okay. Yan na ako. Number 1 checklist niyo sa inyong SAP dapat. Make sure the structural model is finished, the member sections, the material and support assignments. Ano yung member sections dapat na-define kay sometimes mo error ay yung structure if wala ninyo na-define tanan labi na kung daghan na kayo linya, maglaba din yung ulog tuwal, dapat ma-click, ma-check din yung tanan din nga naa siya member ko. According to plan dapat. And material and support assignments. So kana kailangan niyo i-define dapat na jud mo nga data like kung ang gigamit ba nila sa ilang column is 27.6 MPa or 21 MPa ra ba? Kanya ang support assignments, of course, mga building, fixed, sa bridge, pinned, sa inyong kwan, sa pin and roller, sa ends ninyo, sa mga batment. Low definitions, which is kato dead ng kwan. Again, for the those nga nag-stairs, you don't need to kanang model the stairs because it does not help actually. It just takes your time. Ayaw nyo wasting yung time. You can convert it instead to load. So, imagine na lang ninyo ang stair nga mura siya ka ng floor load. Ako yung drawing na lang din niya. Lang. Quantity mo sir kung magkano. Kung mauni inyo ang kuan, kung mauni ang inyong asa inyong stairs, kung mauni yung building. Example mo na mga, sorry, nahiwi. Frame. Kung mauni inyong stairs, iwaan naman ng stairs, o sa plan, i-convert ninyo na siya og since ang stairs ana padulong man na siya sa kuan i-kuan niyo siya tributary area sa dapit ang yung tributary area niya. So padulong man na siya didto if I'm not mistaken. Kay kani man ang ga-carry dinhi kani panaog man ni sa ubos. So kani nga beam ang magdala. So i-solve ninyo pila ang load na convert na to kuan multiply the volume to the load of the stairs and then put it at that beam kay siya may mag-carry ana. Tunga sila sa ground ug same gyapon sa next floor. So kani gyapon katunga ni siya sa kuan gyapon ni design lang kanyo i-solve lang na ninyo. Get the volume, get the unit weight. So you don't need to model the stairs, pwede mo masok. Okay. Second checklist niyo, run the linear static analysis to check if there are no errors in the modeling stage. Why? Okay. Kanang dili lang sa mo fail pud ang members, it is also to check kung ang design pud mismo sa building safe ba jud pud siya. Although yes, dugay na siya nga building jud actually nga kuan. Pero wala lang ba as a checking kay ngano dili man mo run ang pushover kung na mo fail bala pag mao to ang nasa plan. If that happens, pwede man niyo i-add ko inyo lang na ibutang sa inyong sa man scope and limitations or kuan na mo gi-adjust sa design kay katong original design mo fail. Okay, basin pud siguro sa actual pud ana pud. What did you get sa mga groups? Did you get the as built or the as planned na mga plans?
Murag mas nice daw to sir if as built pero sa among case sir kay ang katong as planned lang nakuha na mo sir.
Sige ani na lang siya. So I'm pretty sure nga dili mo siguro jud mo fail na ang tibok structure mo pud siguro jud nga. Nana si certain members, if there are certain members na mo fail, just change the member size ba or ang RC nga niya. You just you write it in your thesis kay para dili mo makuan nga anong gi-change ninyo inyong reason kay katong gihatag sa inyo basing na error typo ana bitaw. Hindi naman na maiwasan kay kung mga old new structures there are always errors yun sa plan kay di mo maiwasan. So I think you know naman how to design RC or kung steel, so you just adjust it accordingly. Okay. Yeah, tedious yung gani siya nga part. Kailangan yun ninyo i-make sure nga safe tanan members before you run a pushover. And then okay. Ni-skip ta actually sa step 4 katong non-linear. Okay. So, ako sa i-run down ng checklist para ma-take note ninyo, pero pili ninyo mo ninyo tanawon pag magbalik ta sa kuan niya model. Sa third, mo ato mo sa assign frames sa hinges. Kani siya nga part, inyong tanan mga beam and columns dapat na siya hinges inyong i-apply sa ends, which is unya makita ninyo. Yeah. Kani, please take note this kay kamo mag-decide mo niya sa group and you have to be strategic unsa inyong i-analyze kay unsa inyong i-focus. Kay in research you have to set a goal. Dili mo pwede nga buhaton niyo tanan. Kailangan na kay shear, na kay flexure, na kay torsion. Choose kana unsa nga failure mode. For buildings ideally interstory drift. Pero if your building is too short, dili kay mag-matter interstory drift. It's not inyong ma-waste inyong time na dili kay relevant ang your results and it will just be a waste of your time. Kay pili mo check na kung example as what I've said sa katong isa ka group nga irregular building. If it's an irregular building, there's a big chance nga na torsional nga failure. So you consider that in your For some actually sa bridges, I suggest pinakadako jud nga mo to among game recommend sa mong study. Make siya kanang shear failure because mas dako ang chance mo fail ang bridge sa failure as a shear failure rather than sa moment kay the columns are really strong against that. Pero sa shear, there's a tendency nga panlab niya sa earthquake. Okay, depende man sa construction methods. So I think maura man na ang unseating for the bridge nga team, unseating, it's a different study. If you can do that, then you're really amazing. Okay, taas yung process pero yeah, you do research on that. Okay, we haven't done that. Pero I also recommended that would may unseating kay bridges sometimes fail not in shear, not in flexure, but matagak ang iyang mga girders. So that's upon you. So kana siya, ang focus niyo sa third nga checklist niyo dapat maka-decide mo sa group unsa nga failure inyong i-focus. What failure type? Okay? And again, additional pod sa interstory drift, actually ma-cut off na inyo ang trabaho kay na may fracas. So you just put your pushover and your response spectrum data. It generates your fragility curve for you na, so no problem na sa inyo. For those nga mag-shear and mag-flexure nga failure, you have to really do an Excel statistical analysis. Okay, 4, we have done it already. Define that load analysis type. Number 5, we have done it already too. And number 6, tapos na din tayo dito. Okay, the target displacement deformation can be obtained in 2 ways, assumption or design basis. Design basis, yeah, you can also design, you can look at the NCP 2015 section 424. There are what do you call that, provisions by the NCP unsa ang allowable na mga deformations, and you can start there. Kung naragay po sa inyo, at least na may options. Okay, so I think mo focus sa 3 dinita karon. Can you go back to the model po, sir?
Okay po, sir.
Okay. Kaning sa define, can you click the define at the ribbon? Section properties. There, top. And hinge properties. Add new property. The concrete, kung sa concrete ni steel. Okay.
Concrete pa, sir.
Okay. That one. You go. Uh, you you can name that, or you can modify or show hinge property. Wait. Wala. Ako check ang notes na. Okay. Paano? Mamani ang hysteresis type. Wait lang a bit. Hello. Ah, hello. Yeah. Actually, this is the later part pa after pa later, because you have to check this. Can you close this na? The cancel. Just click cancel. Cancel. This is the later part. You have to assign X. You close this one. Go to assign. And frame. Go to frame. Frame. Hinges. Here, there. Okay. Hinges na so. Yeah. Okay. First things first, define this mga buttons. When you say you do auto, because may mga hinges based na sa codes sa FEMA and sa Caltrans, and we are using FEMA. The relative distance will depend. Actually, you can just use, it's actually a percentage 0 to 1. Like, can you for example, kanang sa beam, from the start of the beam, that's 0, and then 1 is at the end of the beam. Pero for those nga kanang, actually, I have to tell you this, bala pag kanang libog siya, i-take note lang niya, i-ask lang ninyo sa lesser. Sometimes you can dili siya sa 0 and 1 ang kwan kung shear failure ang inyo consider. Can you click the add hinge? Add hinge siya for the meantime. Yan na ng kwan, the relative distance. I'll put 0 there. You can use ASCII or 0, put 0. Add hinge. ASCII, can you click the drop down sa one? There is ASCII, and I think, that actually integrate na sa ASCII ang FEMA 356. Can you click the lower table, the hinge table? You can see there that here are the failure modes of the structure: concrete beams failure, concrete columns. You have to choose where, kung unsa mo, concrete, steel. Okay. So kung example, this one, concrete beams flexure. Wala na lagi siya axial ba? Okay. Actually, you have seen naman na sa mga failure modes, wala na siya axial. Wala siya shear actually. Pero when you focus on your failure sa shear, your relative distance is not 0 and 1. I think Sir R can explain that nga. Ang failure sa shear actually does not occur at the very end. It's somewhere 5% from the end of the beam. Pwede nyo nyo sila i-ask ang inyong mga professors nga nung nadia ang shear or na-discuss na sa inyo. So when you go back, can you close this one sa muna? Close this box and click cancel. Instead of 0, you put 0.05 or 0.95 for the end. Like kung mag-add ka na nga hinge, 0.05 or 0.95, okay, from start and end, because shear failure happens somewhere there, somewhere in at that distance. The maximum shear, I mean, not the shear failure, the maximum shear of the structure. So for simplicity, for the meantime, you just use 0. Okay, just use 0 for one. And then add hinge. Yeah, you can use the concrete beams texture. And yeah, moment 3, current design. Okay, just click OK. And you can add another one, but 1. The relative distance is 1. Just yeah, 1. Add hinge. And the same. So that's for end and start. Also, and add another one because you need to have 4 because you have columns. Another 0. Concrete columns. Yeah. That's fine. M3. Oh, here. Actually, it's here. Flexure shear. Okay. They integrated it here na pala sa. What version is this? Version 20. Okay. So you can observe the failure of the column either focus on shear or flexure shear. So let's just use the flexure, just flexure for the sake lang of the fun, but you can decide later on. Okay. But if you choose the shear failure later, you can just, it's still dead. Okay. And then 1. Okay. So close. And then you assign this to your beams later. Like you click a frame. If I'm not mistaken. I forgot we can use version. We use version 14. Just click one frame, like just one frame. And then assign. I think you should have frame, but hinges. So the go to the frame. I think you should have clicked the frame earlier and then hinge. Oh yeah, you should have clicked the. You do that. You do the same thing again. Kasi kanina you didn't click any frame pala. I forgot. Sorry, my bad. You do the same because it's the beam. You do that. Concrete beams, flexure, and then okay. And then 1. You do the same. Apply. You can see now. Can you close up that part? Okay. Now you have assigned the hinges. Okay. So you're gonna do that to all of your beams. And the same with your columns. You have to do that with all of your beams and your columns. Pero yeah, actually, that's the idea. Actually, it will take you a long time actually to do that. But after that, if you finish all of that and you already have your dead load, you can go to analyze later. I'm just showing you so that you can know the steps, and then you run the analysis, and then later after your analysis, you can go to display, to the display. You can't run it yet because you haven't finished production, and you can click use show the deformed shape and the static pushover curve. It's still blank, somewhere down the deformed shape and the static pushover curve. From your static pushover curve, I think yeah, you really have to finish the structure actually, so that you can open that. And please forgive me because I really haven't done, because the software talaga is not installed. But you can ask me later on if you have questions when you are done with your model and you have done the defined and the analysis, and you can show now your pushover curve. You can contact me, or You can call me or email me if you have questions as to how to because from the static pushover curve, let me share my screen again. Here. Um, this is the result that you're expecting to see. You see here, there's a file. From there, you can actually get the table of the pushover curve and the performance point. The data that you get there will be the ones you'll be using for your fragility curve. That's the one you will extract for your fracas. That is the one that you will extract for those who will do a statistical analysis in Excel. You're gonna do logarithmic uh, curves so that you can plot your fragility. Actually, it's a text box. You can convert it to Excel file, and then from there you do your fragility curves. So the once you get this, and also, so can I ask how many people are you in your group? Each group right now?
4 to 5 po ata, sir.
Okay. My suggestion is one should already work with normalizing the earthquake data. So you convert the earthquake data to response spectrum, and so the one who will do that, this is your checklist. Number one, normalize it, convert it to different PGAs from 0.2, 1, 0. Until 1, and convert all of them into response spectrum. Someone should do that because uh, you will be the one providing this data sa inyong group so that you will be efficient in what you're doing. You will be the one who will provide this response. Actually, because of the graph is so small, actually it's like this in actual drawing. So it's a response spectrum. One should continue doing the model and getting all the pushover curve of your building or structure and all. And then another one, after the one who does this, should extract the data and combine, get the performance points. This is what you need for your fragility. This is the most important, which is will be on Excel. And then someone else, I think the fourth or the fifth can write, and then yeah, you can work together in creating the fragility curve. So you will be efficient. There should be only one doing the one. So para mas may efficient yung pwede mo makakuha sa time since time is of the essence. Are there any questions or clarifications or yeah. Medyo dili pa masabtan yung concepts or ano.
Sir, katong regarding sa pag-add og hinge, sir.
Oo.
Bale tanan beam, sir, same lang ingato, sir, katong like 0.05, 0.95, and then same lang og kwan, sir, uh, katong na-specify ganina, sir. Like basin unsa klase na beam, basta beam.
Yes. Same ra yun siya kay kanang ang hinge manggod is it's like assigning kuan kanang you're assigning a failure mode sa beam. Kanang kumbaga you put that at the ends because that's where the largest moment and the largest shear sa beam. At the same time sa column, the largest moment and the largest pod nga shear sa column is actually at the ends pod niya. So you do that for all lang jud. Mo na siya nga dili kay siya actually ang pushover is really ang nakalisod lang siya kay kuti kay siya dagay mga ining assign. So you do that the same what you did earlier. You just do that for all the beams.
Oh, okay, okay,
And
okay.
sa column, pero you decide it as a group kung unsa ang kuan, kanang unsa ang failure mode. Kay ang beam kung naman dito final, dili naman mabutang ang shear, flexure din siya. For column, it's up to you kung asa mo mag-focus, flexure or shear. Okay, supposedly, the fragility curve is designed for multiple structures, or kung isa ra siya ka-structure, you present different failure modes. Like sa amo ang study, we did a bridge, and kanang multiple failure siya, pero mula dito, since na-lack mig time, kay wala dili may efficient enough adto, kanang we just did lateral nga push over and longitudinal sa bridge. So mao to siya nga ang multiple na mo is flexure sa lateral ug longitudinal. So okay, you need to come and go to compare results to sorry, layang ko. Sorry. Thank you. For those nga nagkuan sa kuan building, you can ano pwede mo sa flexure kay dagay yung mo feeling structure sa flexure. Meanwhile sa bridge, I suggest nga focus mo sa shear kay dagko kayo ang failure sa shear, which is mas important kay makita ninyo ang data kay kung flexure man gud sa mo niabot og 3G ang earthquake aya pa ni fail ang bridge. So murag bitaw dili kay siya ana ka relevant kumbaga. So I suggest na shear. And nindot mo pud kay namay soil structure interaction diagram, so it's more it's more conclusive, and that's nice. Okay, you consider that if you so mo to siya. So sa mo to sa hinge, kailangan lang jud mo mag-decide unsa ang failure mode, asa niyo siya ipa-fail, and then you're good to go na din for the curve.
Okay po, sir. Thank you, sir.
Napay questions from other groups, basing na yung mga other aspects sa yung study nga medyo na kuan mo sa push over.
Ako mag-question ko. Yan ako yung
Sige,
mga
sir.
Vanguard
Sige,
ba? Pero regardless kung unsa nga failure mechanism ang imo ang i-consider pag abot dito sa fragility curve, almost the same lang gyapon ang process.
Yes, actually the same rin yung process, pero maglahi ang mga fragility curve kay ang probability, of course, kung shear, mulahi yun ang mga failure sa mga structure, kung like mas dako ang chance mo fail sa shear kung inani ang form sa structure, mas dako ang kuan kung flexure. So ana siya.
So at least same procedure ra gyapon sa pag-derive sa fragility curve, dili bag-o, like for moment, like for inter-story drift, like for shear.
Sir, sa inter-story drift, wala na ko siya na-explore kay nag-appeal to sa mga limitation, wala na mo kuan kay bridge man to. Gagamit mo sa fracas, so I don't know, dili ko kuan, wala na ko explore ang fracas nga method. Pero honestly, mas paspas man daw kung sa fracas. So lahi siya ang kuan pod analysis method sa fragility dito. Lahi pod ang sa
Sa
moment
analysis,
sir. Ang interstory rin nakalahi sa three major failure: moment, shear, ug torsion.
lagi no kay sa sapra man mo ato tanan nagbuhat sa fragility curves, no.
Dili sir, nag-excel mi adto, naggamit mi og
Ano,
mga statistic, nag-VLOOKUP mi adto.
nag stochastic mo statistics, okay.
nag-logarithmic dagan kay ito nakalimot ko. Log normal curves mi kay kuha man to like na yung mga okay. I can show you our kanang part of our study para makita ninyo sa dapat ang expected result for those who will choose moment of sheer nga failure. Ako
Sige,
share
sige.
ko.
Ano raw ba?
Oo. Okay. Here is our study. Mo yung ano, kung nakakuha na mo sa data, good. Mas maayo mas dagan yung data para accurate yun yung study. Sa earthquake. Here. Bridge. Lang ako ipadagan para ma-recap lang sa mga students sir. So mo na itong gibuhat ganina. Push dapat wala ni na-click ang continue dapat i-click ni. Time history. Response spectrum. Natin push over curve. If you've noticed, result ang pushover curve ng basic resultant base shear versus monitor displacement, i-change na ninyo sa ribbon. You choose the ATC40 capacity spectrum para convert siya to spectral displacement o spectral acceleration. And response, mo din siya. And mo ni inyong kailangan makuha na data. With your earthquake na naka-normalize from, like example, Surigao earthquake man eh, 0.1 G at this displacement nga kuan nag-yield siya 0.02 ang kuan at ultimate 0.447 mm kuan meters nya kani sa kuan 0. something 537 so ang yang damage state based sa atong among study ay katong among give basehan nga reference no damage so you tally all of this for each earthquake so kani siya Surigao earthquake kani siya itali na ninyo siya actually ni 0.02. Mo tong makuha ninyo sa ingon ko nga Excel file dinhi kani bitaw. Dinhi anay file, makuha niyo yung data. Mo ninyo makuha na data. Kani siya. Pwede niyo na i-export to Excel or convert to Excel files. So mo ni siya taon. Imagine na flexure failure niya siya niabot pag 3G mura nituyok ang earth. Kaya pa siya nag-slight damage. So mo siya. Mo ni basihan sa damage ductility if kuan ang kalimutan sa P basta kanang sigma P is less than 0.7 times sigma yield no damage follow lang ka through follow through lang ka na calculate ang complete damage so kadto from there actually sa fragility curve mo ni yung kuha nga data from there di ba na makita man niyo pila ka book site damage 1 to ihapon na ninyo inyong i-tally tanan earthquakes so like example sa 0.1 pila ka book earthquakes ang naka-cause og no damage 8 na isa nga naka 1 at 0.2 pila ka book earthquakes ang naka no damage 7 2 hantod sa maabot mo dinhi nga at 3G pila ka book earthquakes ang naka slight damage 7 1 1 and if we go back namin 9 ka book earthquake data so mo di dapat ninyong matali and from here you use logarithmic log normal nga kuan statistical distribution ni siya I suggest you I think si Sir Ark o si Ma'am Annabelle or kuan sila ng mga statistical tools kung saan pagkuan gamit ang damage ratio na kani narang equation damage ratio you ask them how to do this actually kung dili mo gusto maglisod sa fracas nga actually di man lisod na fracas more of kuan lang siya kanang kuan lang siya hardware intensive nga madamage inyong laptop kung laptop ni buhaton kay tungod daghan kay siyang iteration kani Excel lang inyong gamiton pero manumano po mo magkuan trabaho ani damage ratio is kani mo na siya ang n is number of occurrences mo to ganina and then sum of occurrences per damage state iteration proportion times the lateral logarithm of the PGA which is pila ang kuan niya of peak ground acceleration like example 0.1 0.2 and from there mo ni natural logarithm niya and mo din ni ang ratio kani n over n kani sila 4.586. Yun yung ibang ratio na 8 divided by ana antod sa kani siya magpatabang mo sa kinsay mga kabalog statistics sa CE department, and then Excel ra gyapon ni makuha na din ninyo ni, which will kung inyo ni i-plot ninyo yung slight damage, moderate damage, extensive damage. So flood na ni siya. Ang result adto kani yung dagway. Nara. Excel rin siya. Ikaw na niyo, kanang graph lang mo sa Excel, magkawas na din siya. I-adjust lang din ninyo ang iyang si term adto. Para dili kay siya murag dili bitaw siya magkuan zigzag kanang kuan siya ba smooth siya nga curve. And from there you do your kanadain mga conclusions. So that's just the general nga flow para at least na may heads up pa how unsang step by step ninyo buhaton. Mao to siya, sir. I hope na
Yarn. Thank you very much, Yarn.
I hope so.
Final na siguro na ko nga question, Yarn ba?
Yes, sir.
Did you have you were using Surigao earthquake man, no? Pero ang bridge is dari sa Cagayan de Oro.
Yes, sir.
Did
Mo
you-
pinakaduol po. Mo
Okay.
pinakaduol nga available nga data sa mo kaya. If you see our data actually sa earthquake, mostly kay gawas sa nasod. And actually ang reason nga kato po na mong gi-use kay these are the most similar ilang soil properties pinaka similar sa Philippines nga kuan ba nga kumbaga from its kanang distance from epicenter, same la siya og kanang kuan data sa same rag properties sa soil sa Philippines kanina mga areas. Nagbutang lamig pinakakusog pero lamig kinamurag kubag maximum which is the Great Hanshin. Kumbaga gibutang na naman na pero mo ni ang pinakataas nga kuan sa curve. Kumbaga wala siya maximum jud ba. And we placed Surigao. Actually sa Surigao mo ni siya. Mo ni siya. 9 ko. Kani nagbutang na mi ani kay para lang jud nga dako ang earthquake.
I am familiar with the procedure mongod ba, pero I did not actually do the analysis, no. So dili wala gamay pa gyud ako ang knowledge. Kabalo lang ko sa procedure. Pero did you need to modify also these earthquakes, no, to represent probable size specific na gud nga kuan site specific conditions?
Kuan, sir, that's what we did nga kuan kay since we can modify it jud nga kuan because it's tedious nga directly jud nga ma-change jud siya. We normalize ang terms actually sa mga references, mga studies, but actually ang mas masabtan nga term actually is scale siya. Like kumbaga ikon siya example katong sa Surigao earthquake man tong ganina. Sa I think na din niya. Si Surigao earthquake, gi-convert na mo siya into response spectrum niya. Gi-kuha na mo siya, scale na mo siya nga. Like example, ang yung peak acceleration is somewhere mga 0.5, 0.6. Na unsa ang dagway sa curve kung ang yang scale, ang iyang PGA is 0.6, kumbaga murag duration proportion ba? Ginamit na mo ang present para murag at least murag naikuan ba nga what if inani yung PGA, so at least daghan nga results, daghan nga same earthquake pero different PGAs. So kay para ma-cover na mo tanan bases ba nga kung mahitabo otong Surigao earthquake pero ni same siya kuan sa Cagayan, so mga 0.1 na siguro ang G, or kung 0.2 ba 0.3 and up to 1 G. So mo to ginormalize na mo siya, gi-scale na mo siya. Mo siya kanina. And until mo dagan kay ni siya, like example kay taman may 3G, so from 0.1 to 3G, so approximately 15 siguro ako kalimutan ko nadia sa mga 30 kay kuan man 1 to 3 lagi. So okay. Approximately mga 30 ka sa isa lang earthquake, 30 ka kuan response spectrum gi-partner na mo sa pushover sa among bridge sa longitudinal of latitude so daghan kay ni siya 30 times 9, so 270 ka earthquake data among gigamit technically. 270 nga amo din siya gipares dayon sa pushover for the longitudinal and latitude. So more or less ang among gipangkuha nga spectral acceleration is 540 tanan.
Okay. So
Ah,
you are leaning towards the conservative side with your responses spectra, no?
Oh, okay. Kuan lang siya kanang since kanang mao po yung practical pod kay wala man mi skills jud adto nga time to do such
Yeah.
mga inana. So amo lang gi-run down tanan to cover
Yeah.
all the bases
I
nga
think
possibility.
I think okay na pod, no? Kay for the here in the Philippines, we don't really have a reference response spectra nga pwede gamiton. So, take note na lang siguro ato mga teams, no?
For now, actually, since nag-develop naman ang bago nga NSCP, ang one thing po nga bago karon kay nanay mga spectral acceleration on each area sa Philippines. If you have researched the Philippine earthquake model, nanatay data na soil data accurate jud kay siya. So, piliton ninyo gamiton as basis kay nanas lang mga sample. Actually, sa bago nga book daw sa FIVOX kay we've worked man with FIVOX here sa DPK. We need the data for our bridges nga gina-design. Nanay mga kuan la mga specific data. So, if you can contact FIVOX sa inyo sa Cagayan kay mas better man nga kamo as a study kay kuha man siya confidential man siya dili mo na mo pwede i-share sa ubang tao kay of course mga inana nga mga data is sensitive, so you have to send a letter to FIVOX and ask them for that data nga mga spectral mga sample earthquakes sa different parts of Philippines because they have that data already. And then kana lang kung gusto niyo nga dili mo gamit ani mga Japan or mga earthquake na accurate sa Philippines, you can use that. Specifically mga Cagayan earthquakes dagan kayo. Kato lang ang yung kuanon. I-request
Okay.
na ninyo siya.
Okay. Thank you very much, Karen.
Yes, sir. So mga teams, wala may questions kasi na may kalimugan sa.
Good evening, sir. Clarify lang.
Yes.
Ang fracas, applicable lang siya sa inter-story drift na failure mode, sir ba?
Yeah, oo. Actually, mo may ginagamit sa mga building na teams pero I've noticed some of your buildings are not that actually low rise man siya based sa NCP. It's considered low rise, so dili kay siya ideal for me personally, pero you can use that kanang medyo lisod tong kuan, pero di siya ideal because interstory is actually mas applicable, mas naagip interstory pero mas makita jud nimo ang dako kay nga difference sa kuan ba failure kung mga ubot na kag let's say mga 10 stories 12 stories ana bitaw, but when you say mga 4 stories dili kayo siya gamat kuan naagip siya pero dili kay siya nakadako. So yeah, pwede rin po kamo.
Pero ang among structure, sir, kay cathedral man. So, unsa kay mas applicable na failure mode ang nagamiton ng
For the cathedral, ideally, para dili mo maglisod kay since kuan man katong gamiton ninyo nga kuan. Pwede mo katong shear and flexure lang jud mo. Similar lang niyo flexure ang duha para since I actually mas nindot ang shear of flexure, shear sa column ug sa flexure sa beam kay since tag-as mag-spans, di ba? Tag-as kay spans ang mga beam o column kay since kuan cathedral man dili kanang di make sure man nila nga taas jud kayo ang ceiling and all. I-check mo yun yung shear and failure ana. Mo na akong suggestion kay sure jud ko given the structure is very old dagan nindot ang inyong results ana. I assure you that nindot ang results sa shear and failure in tanaw. Katong sa Bora katong karon kana hospital murag square man di siya abi na kog nakuan to L to siya gamay kay kung L to torsion jud ako suggest adto niya. Okay.
Sir, murag kulang sila sa building plans sir. Ang available lang sir kay katong big katong balik katong ubos sa letter L katong murag rectangle.
Kana pili ra mo shear o flexure. Pili ra pud mo mag interstory kung pila siya ka story 5 story ba?
At
Or
3 lang sir. 4 kung appeal ang quad. Ang adil naman to appeal ang roof deck 3. Murag 3 lang siya sir.
Pila ang roof deck kung agihan siya tao. Nga feel na pud na ba helicopter nga landinganan dito? Naman siguro, if I'm not mistaken. Pero kung wala, basta roof deck siya, appeal jud siya kay na siya slab. And when there's a slab, it's a big weight. And sure ko na mga beams niya lagi pa bugat kaya na siya ang dagko ka na yung beams. Mana yung i-take note sa roof deck kailangan niya siya i-appeal sa hinges.
Okay.
Mm.
Okay po, sir.
Kung sa tulay wala na okay ra sa inyo ka tulay wa mo naglisod kayo. Na ba yung team din sa tulay katong bridge sa Borja? I think new bridge man to. Ay Borja, Balulang. Di-offer ba yun sa mga bridge? Yeah. I mean, itong pag-start ng sige, sige. Di-offer to sa nakasama mo to among sadihan ba kuan aming ako man human sir wala na magikuha. Kasi unsa yung kuan sa concern sa bridge wala may mga small detail. Kasi di gagamit niyo sa okay, CSI bridge man naglisod mo sa katong kuan yung trapezoidal di ba pa naman na siya kanang ash to mga automatic mga gawas. Okay, sige. Oh. Oo. Sige lang, explore lang ani. Oh my God. Dakuan ko model ko sa bridge pero sa staad naman gud ko so I think I can't help that much siguro. Kung mo na jud ang kung pinaka closest murag mo amo kung sigong study ang pinakaduol sa bridge. Na pwede niyo basihan sa model. So kato lang so if I'm not mistaken, si Simon siguro nagdipan sa mga basta pwede mo siya i-ask kasi siya may nag-model sa mga engine icon si Mr. Cabanas. Pwede niyo siya i-contact siguro kay siya. Kung kadumdum pa to siya. Kani mo ni pasabot ni mo? Yes. Mm-hmm. Okay. Akong kuha na i-explore ang concept sa bearing pad. Dapat gamay na basing i-check. Kalimot na ko asa to i-click pero ang bearing pad mo diya mag-change dapat 1 to 0.00 to siya kay nipis man ang bearing pad basing dako kay ang bearing pad kaning dinhi bitaw sa middle kaning pad. I-check na ninyo ang length ana kay usay mo na maka-fail dili mo dalagan ng model kay tungod dako ra kay yung bearing pad. Kay kadumdum pug kuha na or inana gyud pa namang problem. Yan na-discover na mo kay taas kayo ang yung bearing pad. Dapat katong mga yellow bitaw kuan sa model. Dapat na siya sa taas, wala siya sa ubos. Ang taas na pa ba may model niya? Kani siya. Naman to. Kani. Kita mo na mga kanang yellow nga gagmay din niya. Green day. Dapat na siya sa taas, wala siya sa ubos. Kani siya dapat ma-maintain ni siya. Kay mo man ang iyang spiral bearing pad kay rubber man gud na siya. So mo nang spring kay rubber spring dapat na siya sa taas. Mo na i-check, i-adjust ni ninyo. Kay pag mo man ninyo, kanina man dahil mo diretso katong plastic hinge katong assignment naman din mo diretso. Same ra magyapon ng function sa version 20. I-click lang ninyo. Explore lang. Ang sa mo connect sa LAN. Dapat na ang abutment kay mo man ang inyo ang asa mo kan ba siya kanang additional support ba kung sa kuan ba kaya pun niya sa kilid sa lateral kay of course sa gravity loads these piers are enough kaya ang abutment road naman siya nga sumpay pero in terms of lateral dako kini siya help maka-connect kaning pin ba ang isa ug roller so ang lateral na niya nga resistance dako kay siya help sa inyong structure. So, appeal man na siya sa design sa earthquake load. So, dapat appeal yun siya. Hindi na pwede yung wala. Yung matingala mo ang sa mo ang anong giwala na mo ning dinya dapat na i-peer. Kitungod na may dike na murag gilak na siya nga mulalagya pon siya mura na siya abutment in a sense kay ang pier dili na siya ka-function as what it is supposed to be. Oy, by the way, day ang kani ah mo kumbaga mo na ang bending dun sa ang M2 paana. So kung may earthquake, sorry, nag-comment ko screen sa akong video. Ang earthquake ana M2, M3 paana. Pero night times nga mudako ang imong M3 kung nay lateral. Kay imagine na matuklod ang imong structure paana sa longitudinal, ang imong moment kung nay mga dead load mo kuan siya, mutabang siya padako sa moment sa imong M3 sa imong major moment, so mo to siya. Kailangan M3 ang inyong kung mas dako man M3 actually kung inyong i-check. Kung mangutan na mo sa torsion, kung sa ako ng kwan, pwede rin mo mangutan na Sir Dex, Sir R, pinsa pa yung mga structural ng kwan sa si EDEP. Kung saan siya pag-analyze yung mga kwan. Ano pa yung vote? I feel you guys, I feel you.
Sir, if mag-yes, may fracas sa cathedral, bakit na data ang makuha, sir ba?
Para sa ko irrelevant siya kay the idea of interstory drift is mo fail ang imong structure kung daghan siya nga floor, like ang kaya mo guna interstory drift, no? When you're mo itong ingon kung ibutan sa pinaka-top ang katong yung target displacement, because idea sa interstory drift is when your top joint or top node exceeds ang displacement niya, imagine na nang nagkuan ka kanang sticks na ipatong-patong ni mo na marshmallow, kung kinakadako na displacement ang pinakataas ni mga node kaysa sa imong lower kuan, matumba imong structure. So kung cathedral ka, wala kay gina-compare nga another floor dito sa pinakataas, isa ra ka floor nga ana. So murag bitaw interstory drift ana ta na duha ka buok, ang cathedral gaana ra siya, so irrelevant yun kay siya, like actually dili siya inapplicable siya ang interstory drift unless na yung second floor ang cathedral, kabalo sa plano kayo kay kuha ko nabi na siguro na yung mga pero gamay ra mong good na mezzanine dili yun siya ga-consider nga floor actually sa design structural, so mo na siya.
So,
You really have
logarithmic to yung gi-use para sa atong Excel na gigamit ninyo na.
Natural logarithm na equation sa among study, pwede mo mag-collab sa kanang sa bridge nga team kung kuan mabot na sila na kuan sa fragility nga part. Okay, para sa mo i-take natural logarithm may equation dito, and I really think nga Ma'am Bell can be a good resource for that case. Kuan kabalo man siya kanang kuan statistical. Okay, mo man sa transport dagan man jud kay like kuan statistical. You can ask Ma'am Bell how to do that. Katong equation statistical naman jud to. Gimi mo ran gina-apply sa structural nga kuan. So murag inyong gabuhaton ga-collect lang jud mo sa data ninyo. Inyong i-excel tanan daghan lang jud kay siya. Mao ra jud nakalisod siya actually, nakadaghan jud kay. So kato siya. I-follow na yung equation. Kuan mo to direct naman to dito.
Okay, sir, thank you.
nindot kay karon sa inyo kay tulo mo pila mo tulo ay gito. Tulo mo ka teams nga nag-structural sa mo kay na si kuan fragility kay sa mo kamera to isa wala mi kanang naman na mo ani nga part patudlo maybe kung unsaon. Kay humana na kay kung dili nimo humana wala lain mo humana para sa wala tay mabasihan. Okay. Sa mga nga time ang kami ra ang nag-fragility ang other nga nag-structural lahi man nilang topic about dili man like not related to fragility so yeah and mostly water and material testing so I suggest po ni since tulong mo pag group kanang kung na mga time na may mga kinabanga ra ba jud gyapon ni kanang kon para jud mo kon isod na mag-iya karon nga thesis ay FY kung na may makakuan mo mga ideas banda-banda mo. Eh, kung di mo kasabot sa plastic hinge na patudlok mo sa kinsa na nakasabot sa inyo ha. Kaya no, dili man enough actually yun ang one session para makakuan jud ni siya. Gets jud diretso ba. May pasensya jud kayo kaya ang software jud. Oo. Pero mo to siya.
Sir, sa top, bagyapon ibutang ang katong target displacement shear or flexure.
Pag pwede ra actually sa kuan, pero ayaw sa support. Kung sa inyo sa church, of course, pinaka-top din ang inyo, kay mo man ang only other kuan choice. Sa katong mga building, pwede mo dito sa first floor. It doesn't matter actually. Makita man yung tanan ang kuan. Pwede nyo sa first floor, pero ayaw sa support dito sa first floor ang inyong kuan kay. Of course, ang support dili mo na mulihok unless kung mulihok ko ng yuta padung dito sa kilid. Ang iyang movement man nga paana ang iyong kanawon. So pwede ra sa first floor kung shear or flexure.
Yes, sir.
Okay. Napaka sa office siguro karon garn ba?
Oh, actually kin trabaho nag overtime ko sa among tulay karon kay and nasa tuig karon pa niabot ang tulay.
Unsa pa may sunod ani? Na pa may questions?
Oh,
Kaya ato na ning ikuan si Sir Garn kay late na kayo napasasaya ng office.
Thank you, sir.
oh. Pero bitaw pwede mo contact sa kuha kung wala may question, pwede ra jud ko yung email page para at least makakuan ko kung ipa-check ninyo yung structure o yan. Okay. I've been there too and we needed something like this pod. And yeah,
At siguro to the students, no, I strongly suggest na you will have a break man karong December. I highly suggest na you do not wait for your earthquake engineering na subject. There is like a whole module. There's like a whole module of earthquake engineering and structural dynamics online. Siguro mo inyong i-binge watch pag-abot dito sa inyo kang kuan, pag-abot dito sa inyo kang break. Kaya ron mag-earthquake engineering na mo, advanced na mo kay medyo gamay na lang po ang nabilin po sa inyo mga time kung hulatan ba to ninyo inyong earthquake subject para mas dali ninyo ma-comprehend ang inyong work. Okay? Sige. Kinsa ang host o dani? Si Mile?
Okay po, sir. Thank you.
Ay, okay.
Yes, murag, sir.
Oy, advantage kayo sa inyo kay at least gets ninyo diretso ang mga ipang-discuss sa earthquake ninyo kung advanced po mo. Lagi po. Gamay ra ng sakripisyo kay para magyapon ang inyo
Ay,
ang
Gi-check na ko no around 40 hours ang per module. So paspasan siguro ninyo og sulod nga mga module. Sige.
Okay po,
Kung
sir.
wala na
Noted.
kung wala na mo questions, should we wrap up na? And thanks Sir Garni.
Yes.
Okay po, sir. Uh, in behalf of the PICE XUSC community and officers, we would like to give this certificate of appreciation to Engineer Garnelo Jose Cupay in sincere acknowledgement for imparting technical knowledge and valuable service in the SAP Workshop, Introduction to Pushover Analysis for Seismic Assessment, held via Zoom meeting given this 29th day of October 2021. Signed by Dr. Annabel A. Abuzo, the Director of XUERC, Engineer Arcsid Kabugsa, the Moderator of PICE XUSC, and Mr. Jeremy John U. Morales, the President of PICE XUSC.
Thank you so much.
Let's all give Engineer Kupay a virtual round of applause.
Virtual round.
Round of applause, ha?
Um,
Okay. Garn, once again, thank you very much for giving our students a head start sa ilahang study, no? I hope dili ka sumhan if ever one of them will send queries about this structural analysis.
yes,
So,
no problem, sir. Okay.
okay. Thank you very much, Garn, and thank you very much,
Thank you.
everyone.
Thank you po, sir. Thank you po, Sir
Have a good
Kupay.
evening.
Thank you,
Good
sir.
evening.
Okay, good evening.
Thank
Goodbye.
you.